Welcome to solverfy.
Okay, let's look at our molecules. I've been shown a 4-carbon chain with 2 bromines in wedge dash, as well as a 4-carbon chain with 2 bromines in Fischer projection. And the question is, are these enantiomers, diastereomers, identical, or constitutional isomers? So one thing that can help us here is just determine the stereochemistry of each stereocenter and see if they match or not. So I'm going to add the implied hydrogens to our wedge dash drawing. I'm going to number the substituents on each of our stereocenters in terms of their priority, starting on the left here. I'm going to say bromine is the highest, carbon attached to bromine is the second highest, carbon is the third, and hydrogen is the lowest priority. Then I connect 1 to 2 to 3, okay, and I get counterclockwise. And counterclockwise, when 4 is in back, I'll say 4 in B, means S. Okay, so our first stereocenter is S. Great. All right, next. I'm going to do the next bromine. Number 1, next carbon, bromine is number 1, carbon attached to bromine is 2, carbon attached to 3 hydrogens is 3, and hydrogen itself is 4. And I connect 1 to 2 to 3. Great. Is that clockwise? That is counterclockwise. Counterclockwise, when the lowest priority substituent is in the back, again, that is S. All right, so we have S, S. One thing that I'll point out that is true when you have exactly two stereocenters, if you get the case where they are SS, then it cannot be a meso compound. If RR and SS can never be meso, just worth keeping in mind. Okay, well now let's determine what the stereocenters are over here. Okay. Now recall that the meaning of a Fischer projection is whatever's on the left is coming towards you, whatever's on the right is coming towards you, whatever's on the top is going away, and whatever's on the bottom is going away. Which means that if your lowest priority substituent is on the left or the right, it's not in the back, but if it's on the top or the bottom, it is in the back. Okay, so then let's start at carbon 1 here, or carbon 2 as it were. And number or order the priority of our groups. Bromine is the highest priority. Carbon attached to bromine is the second. The methyl group is the third. And hydrogen is the lowest. I'm going to connect 1 to 2 to 3. I get clockwise. But because my number 4 is on the left, it's not in the back. So clockwise 4 not in back. That implies S, whereas clockwise, if 4 were in the back, would be R. So my first stereocenter here is S. All right, whether or not your lowest priority substituent or your number 4 is in the back or not swaps whether clockwise means R or S. Okay, final time here. Bromine is number 1, carbon attached to bromine is number 2. Methyl group is 3, and hydrogen is 4. Connect 1 to 2 to 3, 1 to 2 to 3. And that was clockwise. Okay, clockwise is 4 in the back. No, it's on the right. Anything on the right or the left is coming towards us, so 4 was not in the back. All right, so clockwise corresponds to S. So once again, S and S. Well, if I've got a 4-carbon chain with a bromine on carbon 2 and a bromine on carbon 3, and it's SS, I think I've got identical molecules, right? Each of these is in fact 2S, 3S, 2, 3, dibromo, butane. They are identical.